Hi, everyone. Welcome to P7, the session on human aspects. I'm May Nagappan, an associate professor in the David Cheriton School of Computer Science at the University of Waterloo. And we have 6 talks today in this session, 3 technical talks, 2 journal first talks, and a near talk. And we'll start with the first talk, which is a journal first paper called What Predicts Software Developers' Productivity? And today, Emerson Murphy-Hill from Google will be presenting the first paper. Emerson?
Thanks very much, May. Let me share my screen. So yeah, I'm a research scientist at Google. This research, though, was a collaboration between Google and ABB and National Instruments. And so here we're trying to learn what makes developers productive. So let's think of productivity in terms of a metaphor. We can think of an organization like Google or any organization that makes software as a machine, and the machine has a bunch of knobs on it. You can turn the knobs to make the machine do different things, or to make the outputs faster or slower, to make people more or less productive. And different people control different parts of the machine. So there's developers and managers and executives, and they have all different sort of knobs that they can turn on the machine. So, a developer at the top, for instance, could do a couple of things to improve their productivity. They could spend more time seeking out the best tools and practices. They could shut down email notifications during the day. And so they could do all of these things, but they really have limited investments and time that they can make to decide what they're going to do. So which of those two as a developer might they decide to invest in? In the middle there, a manager has sort of different knobs that they might turn on the machine. They might invest in refactoring on their team to reduce code complexity. They might give developers more autonomy over their work. And the last person, the executive, they might create new teams and new orgs to invest in better software development tools to improve productivity, and invest in less distracting office space. So different things people might do, again, but people's resources are limited and their time is limited. So there's only some things that they can do. So the question is on a software organization, what are the knobs that people can turn? Or, back out of the metaphor, what are the factors that influence productivity? Let's pick a couple of those, better software development tools and less distraction. These can come from prior work. So in this research, we looked through a bunch of systematic literature reviews and meta reviews about what influences productivity. Some of these papers, like the one on the right, were specifically about software development. Some of the ones on the left were from industrial and organizational psychology. And so we combed through a bunch of these papers to try to pick out these factors that prior work says influences productivity for developers or for information workers. And in total, we derived 48 different factors. Now, there was more than this, but we had to sort of condense them, and we got some details about that in the paper. So the less distracting workspaces, that, for example, comes from this instrument called SmartWow. Better software development tools come from the systematic literature review. And so there's a bunch of these things that prior research says improves productivity. But again, the question here is, if we've got a bunch of choices of things we can do to change productivity, where are we going to make those investments? So what we did is we took these 48 factors that we had, and we turned them into statements that a developer might agree with or might disagree with. So the better development tools, I use the best tools and practices to develop my software. Someone might agree or disagree or strongly agree or strongly disagree with that. Or they might say, I have few interruptions or distractions while working. They might agree or disagree with that. And so the trick here in this paper was correlating that with a single question that we asked, general question about reaching a high level of productivity. So people can, again, agree or disagree to some extent with this question. The question is, where's sort of the strongest correlation? Where are the strongest correlated? What are the weakest correlated between the reaching a high level of productivity question and all of these 48 different things? The stronger the correlation, the better. And we argue, the all else being equal, that's where you should make an investment. So what we did is we, after developing the survey instrument, we deployed it at 3 companies. So ABB was one of them. Google obviously was another, and National Instruments. And it wasn't just a correlation. We did some regressions here to try to control for some factors that we know influence productivity. So we asked for people's genders if they decided to provide it, their tenure, how long they've been at the company that they've been at, and seniority, which is, senior developer, junior developer, and so forth. And so briefly, what the results look like is this. Here are some of the top productivity factors. So it turns out job enthusiasm was one of the strongest predictors of productivity. The second most strongest one was people on my team are supportive of new ideas. So Google, we typically call this psychological safety. Turns out to be another one of the top things across the three companies. The next two, my job allows me to make decisions about the methods I use to complete my work, and my job allows me to make decisions about managing my time. Two types of work autonomy that prior work suggests influences productivity. And then the fifth one, people who write code for my software are highly capable, efficient, thorough, communicative, and cooperative. That turned out to be a pretty strong predictor of productivity also. So the argument here in this paper is like, these are, if these are knobs you can control on the machine, these are good ones to invest in because they're going to correlate strongly with self-rated productivity. Some other tidbits from the paper. Some of the factors were really consistent. So support for new ideas, the psychological safety, very consistent across the three companies. And also receiving useful feedback about job performance, that was also super consistent across the three companies. Some are more inconsistent though. So accuracy of incoming information. So this isn't to say that different companies' information was more or less accurate. It was just that affected productivity differently at the three different companies. And likewise, use of the best tools and practices, that varied from company to company in terms of its effect on productivity. With that, happy to take questions.
Thanks, Emerson. You were right on time. And I have one question from Daniel, who says, there are a lot of ways of measuring productivity. What was your definition? How would you account for the fact that the easiest way is to lower quality?
Yeah, there's lots of ways to measure productivity. We experimented with a few different places, and our team in general is called Engineering Productivity Research, and so we try to study productivity. There's a bunch of ways to do it. I'll say our general philosophy is we do it in whatever way makes sense for the research question that we have. In this particular situation, self-rated productivity was kind of the way we wanted to go because we thought it was the thing that sort of everybody could answer. There's objective ways for measuring it too. None of them particularly great. You can look at the amount of output people have in terms of lines of code per unit time. But yeah, quality enters into a lot of people's definitions at the same time. So this one, our definition that we gave to developers to answer didn't include that quality component, but it is included in many definitions.
Thanks, Emerson. And I see no other question, but I have a question. Working with even one company is challenging, and you can do that because you're in Google, but how was the enthusiasm from other companies to work on this project? Or what did you do to kind of get this going? Like a survey across three companies is quite rare.
Yeah, so collaboration with sort of pre-existing relationships with people definitely helps. I'll say that, yeah, company collaborations can be tough. People have intellectual property issues that they're worried about. This was a little bit straightforward. If you have like a survey instrument that you already developed, you've already run it with 400 people at your company, that's pretty good. It's not so hard for someone else to run. That's pretty good. We had to make some sort of privacy guarantees. So I was when I did this research at the other companies, I think I was still a professor, and so when I looked at the data from the other companies, I made sure that we didn't share how productive Google developers were compared to ABB developers. I don't think that's a useful way to think of it, but we had to sort of make some privacy guarantees just to make sure that different people at different companies were comfortable with the types of analyses and the types of data we were dealing with.
Perfect. There's a couple of more questions, Emerson, but it's time to switch to the next. So I'll just read the questions out, and maybe they can meet you at the meeting room in the third hour and ask you in person. but there's one which are other unproductive factors at the end of the other spectrum, at the other end of the spectrum. And can you briefly describe the inconsistencies you observed for the use of best tools and practices? I think they're great questions, but we're going to have to move to the next presenter, unfortunately.
Sounds good. Thanks very much.
Yep. So the next presenter we have is Kushumi. She is a PhD student at Monash. This is her first ICSI, so we'll welcome her with a big round of applause. And she's going to be presenting her near paper on towards understanding emotional response to requirement changes in agile teams. Kushumi, do you want to share?
All right. So hello, everyone. I'm Kashumi Madampe, a PhD candidate at the Humanist Lab at Monash University, Australia. So today I'm going to present our paper towards understanding emotional response to requirements changes in agile teams. The co-authors of this paper are Ashina Hoda from Monash University and Paramveer Singh from University of Auckland. So this paper is guided by the question, how do agile teams emotionally respond to requirements changes? And we have a couple of definitions in our work. This can be found in our paper. To begin with, I would like to tell you a bit about the project on which this paper is based. So this is based on my PhD study, human-centric requirements change management techniques for software development teams. So this has 3 phases. So in the pilot study or the phase 1, we interviewed 10 agile practitioners and found technical responses and emotional responses to requirements changes. So today I'll be presenting the emotional responses, and the technical responses were presented last week at the Chase workshop. So the reason why we went with Agile in the pilot study was because Agile is all about embracing changes, and so a number of requirements changes were abundant. And for data analysis, we used an experimental approach with grounded theory and sentiment analysis. The reason why we went with grounded theory is used in studies where human and social aspects are studied, and sentiment analysis was used to extract the emotions. Moving on with the method, so we started with grounded theory analysis and found the stages of requirements changes where emotions were shown. And the key points from grounded theory analysis was passed to sentiment analysis to find the polarity of the key points, that is positivity, negativity, and the neutrality of the key points. And then we moved with the job emotion scale analysis to get the emotions of the key points. And moving on with the findings, center strength analysis resulted in that the positive emotions followed a high, low, high pattern, and the negative emotions decreased drastically from receiving to implementing to the delivering stages. Job emotion scale resulted in that at the receiving stage, negative emotions were shown highest, as reported by the participants, and the teams were frustrated and showed no feelings the most. So this was by considering all positive, negative, and neutral emotions at this particular stage. And going to the implementation stage, the positive and negative emotions were balanced, and teams were much frustrated and depressed, as reported by the participants. And at the delivery stage, positive emotions were shown highest, and teams showed enthusiasm the most. So we had a couple of differences in the polarity results from job emotion scale analysis and sentiment strength analysis results. So 1/4 of the results were in contradiction, and we found that the sentiment strength analysis results has to be complemented by manual analysis using job emotion scale and grounded theories analysis for final results. And also the findings raise some interesting questions, such as whether different types of requirements changes result in different emotional responses. And also what about the impact of emotional responses on productivity, quality of created artifacts, and the quality of decisions. Plus what about the other human factors, and do they impact on the productivity, quality of created artifacts, and so on. Also whether there's a connection between emotional responses and other human factors. So some of the questions I mentioned here are from the reviewers of the paper. So in the future, we'll be studying the responses of software developers to different types of requirements changes. And also we'll try to incorporate other human factors to emotional responses to find the impact on productivity, quality of created artifacts and decisions. And also we'll retrieve direct sources of emotional responses by mining software repositories and using experimental sampling methods where I'll be capturing the emotional responses and technical responses at the same time. Plus, software engineering focused sentiment analysis tools will be used because we are expecting technical jargon to occur in the coming data. So this ends my presentation. Thank you very much for your time and attention. And I also like to thank Department of ECSC at University of Auckland. So that was my previous department, and thanks a lot.
Thank you. Thank you so much, Kashumi. And we'll give a second for the questions to show up, but I have a question for you. One of the things in future work you said is that different requirements might elicit different responses. Do you have like maybe what kind of requirements you think are, is it more with respect to size of the requirements changes, or is it more with respect to the type of requirements changes?
That can, the type and the size can be both, because right now we are conducting a survey to find the aspects of requirements changes. So both can be there. So that will come in the future work, yeah.
And I see another question from Ita Richardson, which is, have you done any gender analysis? This would be very interesting.
No, not at the right moment, but some other person in our lab is working on that. So you can get interesting work coming from our lab, but that's not in my scope.
Okay. Maybe there is something to add to the scope as well, right? Perfect. And I don't see any other, oh, I see one more anonymous question, which is, I think you mentioned developers were increasingly happier at the delivery stage. Do you know why that is?
I think they are more satisfied with the delivery because at the very beginning, they are frustrated, and by going on with the implementation and delivery, so they are off with the work. So I think that's the reason, but that requires further investigation. So as I said, this is very much a preliminary work that I did last year. So that requires further investigation to come with such a verdict. Yeah.
Okay. So we'll move on to the, thank you, Kashumi. And we'll move on to the next talk, which is from John Whittle at Monash University. It's a technical track talk on a study on the prevalence of human values in software engineering publications from 2015 to 18. And it has the artifacts available badge on it as well. John, the screen is yours to present.
Great. Thank you very much, May. So we've had over 50 years now of software engineering research and practice. So this is a photo from the 1968 Garmisch conference that you'll all know is the first ever software engineering conference. And I think it's fair to say that in those 50 years as a community, we've done a fairly good job of building, coming up with methods and tools to build software systems at scale, at a functionality, with the functionality that we want, at a cost that we can afford, and that for the most part take care of things like safety and security and even recently data privacy. However, what I'm going to argue in this talk is that there is a much broader set of what I call human values that we really haven't addressed at all in software engineering. So things like inclusion, diversity, social responsibility, transparency, well-being, fairness, and respect. We don't really consider these things at all when we build software. And that's a problem because, software is increasingly pervading our society. It's increasingly making decisions for us. And so if we don't consider these human values, we're in a danger that we'll actually develop software that doesn't respect the society that we want to live in. And of course, this is a hot topic area right now with the rise of artificial intelligence. So we've already seen lots of examples of AI systems that have been deployed and are then found to be biased or unfair or exhibit a lack of transparency and things like that. The response to this across the world has been for governments to create AI ethics frameworks. So most countries now have produced some guidelines on how to develop responsible AI systems, our own in Australia. But the problem with these is really twofold. First of all, they're very, very high level. So in fact, if you look at the Australian version, it has 8 principles for developing AI systems responsibly. The third principle just says you should respect human values, but doesn't give the software practitioner any concrete guidance of what that actually means. And the second reason why these are problematic is because it's not just AI systems that need to think about values. Any kind of software system really needs to think about values. So I made a claim earlier that software engineering research really hasn't addressed human values. And that's the key research question that this paper is trying to address. Given 50 years of software engineering, have we really ignored a huge set of human values, or have we not? So what we did, we decided to carry out a study, and we looked at the papers in what are generally considered to be top software engineering conferences and journals from the 4-year period between 2015 and 2018. And we did an analysis of their abstracts, and we tried to figure out, did the research contribution in that paper address one or more human values? Now, in terms of how we did this, we had a number of issues that we had to resolve. So first of all, we needed a definition of what human values are, and I'll give you our definition shortly. We also had to select the papers. So we really focus here on what are considered the elite software engineering conferences and journals. And then we would read the abstracts and try to map the main contribution of those papers to one or more of the values in our definition. When we did a pilot study on this, we realized that almost any paper could be considered indirectly to relate to a value. So even if you take a deeply technical paper that is aiming to produce a tool that will help software productivity, you could make an argument that that is going to make society a better place because people will be more productive and so forth. And so you could map that to values. So that we call that indirect relevance. We're not so much interested in that indirect relevance in this paper. We're really interested in papers that their first and foremost research contribution was to directly address one or more human values, and that's what we call direct relevance. The process that we followed is that we had independent raters go through the abstracts for each of these papers, more than 2, or at least 2 in each case. And then we had a process to resolve any disagreements, which involved trying to reach consensus. If consensus couldn't be reached, bring in a third person. And there were a few papers that even at the end of that, there were still disagreements, and we just decided not to classify those. So this is the definition of human values that we've used. It turns out that values have been studied for decades in social science. So this is a definition from a social psychologist called Shalom Schwartz. And he did studies across lots of different countries and cultures to try and figure out what we consider as human beings to be values. What do we find important? And he found 58 different human values classified into 10 categories. These include what we might normally think of as ethical things. So, inclusion, fairness, equality, those kinds of things, but also considers things that are not normally considered part of ethics. So things like respect for tradition or ambition or creativity or fun. Or even things like obedience and helpfulness and spirituality and things like that. So these are all values. And by looking at these papers, we wanted to figure out how many of those values have been addressed in software engineering. And as I said, we looked at what are generally considered to be the top software engineering venues. So the 3 primary tracks in ICSE, FSE, and then the 2 top journals, TSE and TOSM. So in total, we analyzed about 1,350 abstracts. So what did we find? And before I tell you what we find, just to give you an example of how we kind of mapped abstracts to papers. So these are extracts from various abstracts. So the first one there, improve the energy efficiency of mobile apps. That's clearly got a kind of environmental prerogative around it. And so that maps to the value of protecting the environment. And then the second one there, it was about a paper that was creating a portal to support people who were new to OSS projects and trying to help them to become part of that community. So it's really about helpfulness. And this is what we found. So you may or may not be surprised by this result, but we found that only 16% of that top software engineering work had directly addressed one or more of these human values. In other words, the vast majority of papers that we produce in the software engineering community pretty much ignore the broader set of human values. If you dig down a little deeper into that, you'll see that most of the papers that did consider human values focused on security and privacy, not surprisingly. Next was things like benevolence and universalism. Benevolence relates to, user interface papers, that kind of thing, that were generally helpful to people. Universalism, because there's been a rise in recent years in papers addressing software sustainability, environmental sustainability. Interestingly enough, if you take security and privacy out, because that's obviously been studied a lot, that number of 16% actually goes down to 10%. So only 10% of papers ignoring security have addressed human values. And perhaps most worryingly, if you look at that 58, that set of 58 human values by Schwartz, 60% of them had never been addressed at all in any software engineering paper that we studied. So things like, family or curiosity or intelligence or meaning in life, respect for tradition, having an exciting life and so forth. These have never been considered at all. So to conclude, what we essentially found was that, as we somewhat expected, top software engineering research really has paid very little attention to this broader set of human values. We think it should, because software defines society. And if we ignore 60% of what we determine makes us human, then we're going to end up with a society that doesn't reflect the society that we want to live in. You could argue, of course, that not all software engineering papers should address values, and I agree with that, because many of them are just deeply technical papers. But by putting a number on this of 16%, that allows us to ask the question, well, how many should? Is 16% good, or should it be 20%? Should it be 30%? What should it be? And the final conclusion is that we use this Schwartz model for values, which is from social sciences, which sometimes worked well for software engineering, sometimes didn't work well. And it might be worth putting a little bit of thought into trying to adapt that model to a particularly software engineering context. And with that, I will finish, and I'm happy to answer any questions. Oh, and by the way, you should watch our video that we produced that was available in case there were technical problems. It's produced by the amazing Harsha Pereira, and you can find that on the ICSI YouTube site.
Thank you, John. There are a lot of questions. I'm going to go through them one by one. So Daniel asks, I'm curious how other fields would fare on this metric. And do you think there are subfields that do better, like computer music versus network router design?
Yeah, that's a good question. And of course, we don't know because we haven't done the study. So one thing we stress in the paper is that we've only considered what are considered to be the top software engineering conferences here. And it's possible that if you go to some other conferences, we might fare better. So, HCI, for example, or even requirements engineering, that work would need to be done. But even if they do fare better, I think the point still holds that if, the best of the best in software engineering only has 16%, then that even if the work is out there, that means that it's not getting any attention in the ICSI and TSC and TOSM community.
The next top voted question is, can you elaborate on relevance? Do you mean the paper sought to improve how the software treated the value, or was it sufficient to talk about security bugs?
So the definition of relevance is in the paper, and direct relevance. What it means is that the main research contribution of the paper had to address that value in some way, so produce some kind of solution for part of that value. So if it was finding security bugs, then yes, that would map to security.
Okay. Then Igor asks, so the previous question was from Neil Ernst. The next question is from Igor. Did you analyze which stakeholders are the papers concerned about? Users versus engineers, for example?
No, we have not done that analysis, no.
Okay. And there's an anonymous question, which is, I'm curious to see how many papers of the papers were from the SEIS track?
Yeah, so we actually have a graph on that in the paper, and certainly that SEIS, not surprisingly, has a much higher percentage. I don't remember the number off the top of my head, but you can look in the paper. The other thing I should say as well, we've made all the data available as an artifact. So if people want to go and kind of interrogate that data by themselves, we're very happy for them to do so.
Thanks, John. There's one more anonymous question, which is, do you think all human values can be addressed in software engineering, or some values that aren't applicable to SE?
Yeah, well, that's a great question. I actually think they can. So just to give you an example of that, take the value of love. So you know, when I present on values, I often have people say, well, you know, love's a good value, of course, but you can't expect software to address that. But I think you actually can. I mean, again, it comes down to this thing that, you know, especially with AI, software is defining society now. It's defining the future society. So if we really are saying we can't address love in software, then we're basically saying that we want a world without love. And I don't think that's what any of us want.
And I'm gonna ask one last question, which is, how do we promote researchers to conduct more studies on addressing neglected human values?
Well, that's what we're trying to do. So we've got a small team at Monash University called the Overflow Lab. We're very happy to kind of share what we've found so far. We've been working on this topic for about 3 years now. There are some other groups as well that are working on this around the world. And the kind of, you know, broader question of kind of ethics and software engineering has been studied to a certain extent as well. So I think we need more of it in software engineering, more of it in ICSE, and we're very happy to collaborate with people.
I think this is a great start to, even though we knew this, it's a great start to like concretely say that, look, we're not doing enough and we need to do more.
Yeah.
Thank you, John. I think that's about the time. So I'm going to switch to the next talk, which is another technical paper and on pushback in code review, characterizing and detecting negative interpersonal interactions. And this is going to be presented by Carolyn Egelman, who's a user experience researcher at Google, and this is also her first ICSE, so welcome to ICSE, and please take over, Carolyn.
Thanks, May. Thanks for that great introduction. So as May said, I'm a researcher at Google, and this is actually in the same team as Emerson, who presented earlier. And this is some work that we did looking at detecting pushback in code review, or specifically predicting negative feelings about code review. And the paper covered 3 research questions. We looked at frequency of negative experience with code review, which factors are associated with pushback occurring, and then which metrics can actually detect author perceived pushback. 8 minutes is very short, so I'll only be covering 2 of these 3 questions. Of course, please go check out the paper if you're interested in more details and in research question 2. I'll start with the definition that we used for pushback, which is the perception of unnecessary interpersonal conflict in code review while a reviewer is blocking a change request. We had most of this definition going into the study developed from prior work, but we did actually alter this definition a little bit through the first phase of research, which was interviews. We used many different methods here to collect data as part of the study. We started with interviews, and that covered 14 Google developers, and those were interviews about code review pushback, and it covered defining pushback as well as dealing with pushback when it occurred. We then took insights from those interviews to develop 3 logs-based metrics. And why it was important to understand how developers dealt with pushback was when it occurred. We thought that would be a good indicator of a metric that would be able to detect someone dealing with pushback. The metrics that we developed, they're all logs-based. The first one is rounds of review. So that's a batch of comments that would be sent back and forth between an author and a reviewer. We also looked at active reviewing time. So that's time that a reviewer spends in the code review tool, looking at the code and providing comments. We also looked at active shepherding time. And that's the time that an author of a code review is shepherding that code review through the process. And so that's going to be time spent in the code review tool, and also time spent working on that code, incorporating changes from comments from a reviewer. These latter two time-based metrics, they are pieced together across logs from various tools at Google. So they're actually active time spent metrics. It's not an elapsed time between two calendar stamps. There's some more details on that in the paper. We then ran a survey. So we surveyed over 1,300 Google developers to test if our metrics predicted feelings of pushback. And that survey covered overall perceptions of code review. We had them rate 2 selected code reviews, and those were selected. It was a stratified sample based on different combinations of the metrics. And then we asked them for problematic code reviews. This last section was really kind of an insurance policy. We weren't really sure how well our metrics would do, and we wanted to be sure that we were collecting good data on cases where pushback did occur, so that we could either refine our metrics, or if we needed to start from scratch, we would have a really nice set of data to start from in terms of what code reviews looked like when they went bad. Getting on to results, first research question about frequency of negative experiences. We found that 87% of Google developers are satisfied with the code review process. 96% of them feel like it improves code quality, yet 57% report a negative experience at least once a quarter, and actually 26% report a negative experience at least once a month. So while developers are are satisfied with the process and finding it useful, there are sore spots. Negative experiences do happen. We intentionally asked a very broad negative experience. We didn't ask about specifically pushback. We didn't give our specific pushback definition as part of the survey. We wanted to get an upper bound in terms of negative experience. We think pretty strongly that actual pushback in terms of conflict and blocking behaviors consistent with our definition is much, much more rare than this 57% kind of number. Moving on to research question 3 and on to metrics. So this was a quantitative analysis of our survey data, and I'll build up results here to walk you through our primary results. We did a logistic regression predicting feelings of frustration based on the combination of our metric flags and a bunch of controls as well. The way to read this is that authors of code reviews with a long shepherding time are 9.9 times more likely to report frustration than a review with that review than an author of a code review that's not flagged with any of our metrics. The long reviewing time and long rounds metrics by themselves weren't statistically significant. It gets really interesting when you start looking at combinations of metric flags. In particular, a combination of a large number of rounds of reviews paired with long time on either the reviewer side or the author shepherding side. That's when you start getting some very large numbers in terms of how much more likely an author is to be frustrated with that code review. Of course, we also want to look at the combination of all 3 cases where you have a code review that's really getting a lot of attention. And again, kind of a very large number there, 45 times more likely to report frustration. Frustration was just one of 5 different feelings of pushback that we covered as part of the survey. We also looked at feeling like acceptance was withheld, feeling that excessive change was requested, and feeling negative about future code reviews. You can see in particular that combination of a long reviewing time and long number of rounds of review, or having all 3, those were strong indicators of an author feeling acceptance was withheld or that excessive change was requested. Notably, none of our metric flags were statistically predictive of feeling negative about future code reviews. We had one final feeling of pushback that we asked about, which was we directly asked if there was interpersonal conflict in the code review. And this was kind of an odd nuance of our data, which was that actually none of the unflagged code reviews in the study included conflict. So while that's really positive evidence for the utility of our metrics, it is a statistical challenge, as that means our model suggests our metrics are perfect indicators of predicting conflict. We certainly do not think they are perfect indicators at all. There are certainly can be situations where interpersonal conflict occurs and it doesn't get flagged by any of these logs-based metrics. But we do think it is positive evidence in general that these metrics do have some utility. That'll bring us to conclusion and discussion. I've got 4 things to cover here. The first is around pushback frequency. So we see that while negative experiences did happen for engineers 57% of the time, pushback is pretty rare itself. It does occur in code review at Google. we see that our metrics actually performed quite well. They had a high recall and a low precision. That means that they are detecting code reviews that are much more likely to include feelings of pushback for authors. The metrics are also useful at filtering out most of the uneventful code reviews, of which there are a lot. And they would have actually detected 93% of those volunteered problematic code reviews. So we feel like these metrics are doing a good job at capturing most of the high pushback events, but they're flagging a lot of things that are innocuous. And that low precision suggests that there's certainly more work to do to improve these metrics. Next, we see that third parties see similar detection to feelings of pushback as authors. So we had engineers rate 2 code reviews. One was their own, one was somebody else's that they weren't involved with. And what we are taking away from that is that this is a positive indicator that a previously uninvolved person, like a manager or a mentor, is likely to observe pushback within that code review if an author does reach out for help and advice. So it's really nice validation in terms of an author not feeling alone in those feelings of pushback in a code review. Finally, I want to cover uses of these metrics. We think there's one highly appropriate use of the metric, which is highlighting interactions that may benefit from a self-intervention. So you can imagine a flag in a code review, a notification in a code review tool that might pop up a message saying this code review is statistically exceptional and recommend following off offline or reaching out to a mentor or manager to discuss the code review. We think that there are quite a few inappropriate uses of these metrics. The first is flagging reviews to management or HR. Second is a justification to say that a change request has gotten enough feedback. And certainly these metrics cannot and should not be used as a substitute for human judgment or empathy. And with that, I'm very happy for questions.
Thank you, Carolyn. There's quite a few questions popping up. The first one from Kevin is, did you find that social and cultural backgrounds made pushback more or less likely?
Social or cultural backgrounds. So we controlled for tenure at Google, so time being here at Google. We did include some controls for time zone, as well as, I believe in some of the regressions we included region. Didn't find any of those to be strong indicators. We specifically didn't segment data by any kind of geographic groups or ethnic groups to be able to look at that specifically as part of this work.
The next question, I think this kind of answers it, but the next question from Daniel was there a correlation between job level or experience and in both whether people were likely to push back or be the victim of pushback? But I think you just kind of answered that.
Yeah, I can talk to that a little bit. And we did control for both tenure and level. We did see, I believe in one of the controls, there were a couple of cases where lower level engineers were more likely to get pushback or be flagged with pushback. There were actually 2 notable cases that came up in our qualitative analysis of the comments, which was there are some situations where somebody is new to a team or undergoing specific mentoring from somebody, where those are cases where their code reviews may just get more attention because they're ramping up or it's meant to be more of a high touch interaction. And our metrics do flag some of those as being high interaction. And so that is a case where we do flag some false positives, where we say it's pushback, but it may actually be a mentoring situation. Hopefully it's a good mentoring situation. You know, those can go wrong too, or someone thinks they're being helpful and they're not. But, yeah.
So the last question that I have is, it has been known for a long time that code reviews are difficult for the authors. Was there anything special at Google that made this research important now?
I don't think there was anything particularly timely about motivating it, other than I think we felt that our metrics pipeline that we develop and maintain was at a healthy enough point where we actually could use it for something like this. And we thought that it was a good time to actually test and see how well our metrics could do at predicting something like this.
Great. Thank you so much, Caroline. And with that, I'm going to move to the next presentation. This is the last technical talk in this session. It's engineering gender inclusivity into software, 10 teams tales from the trenches. And it's going to be presented by Anita Sarma from Oregon State University.
All right, cool. So thank you, May. And our great students did this work, but most of them have graduated. So here I am. Before we start talking about how to engineer inclusivity into your software, first question you might have is, what is the connection between gender and software? And the answer is actually, most software has gender bias bugs. If you ask where, it's in the very software you create and also in the tools you use to do it. Here is data from a set of 17 teams that evaluated their own software using a method called GenderMag, and I'll talk about it shortly. If you can see the bars over here, the shortest bar is 12%, biggest 100%. On average, in 32% of the cases, teams found some sort of gender bias bugs in the very software they were creating. The question then is, like, does it matter, right? The answer is yes. Going back to John's talk, because inclusion is, an important part of software. And it matters for the day-to-day use of the tools is because every time an individual hits one of these gender bias bugs, they're actually paying a cognitive tax. So what can you do about it? Some of you already know this method called GenderMag, but let me give you a brief overview. GenderMag is a method to find and fix inclusivity bugs in your own software, and it uses personas. So there are 4 personas, Abby and Tim. Abby and Tim are the opposite ends of the spectrum, and they're representative of a range of users from the perspective of 5 cognitive facets. One example of that is how do individuals learn technology. Abby's of this world like process-oriented instructions. They are process-oriented learners. Whereas the Tims are tinkerers. They poke, they push, they prod, and they learn. We chose these 5 facets because empirical studies have shown that individual differences in how people problem solve cluster by gender. If you can see this graph, this is data from one user study, and this had only 2 genders in this case. The orange represents women and green represents the men in the study. And you can see that more women than men tended to be on the left-hand side, which is Abby's facets, and Tim's were on the right-hand side. So the question then is, if the software tools and technologies are built by the Tims, for the Tims, then a lot of the Abbies are left behind. And that is why it's an inclusion problem, a gender inclusion problem. So with the personas, what teams do is they walk through their user interface to see how these personas might carry out functionality. If they think that the persona might have a problem because of these 5 cognitive facets, they mark it as a gender bias bug. Past research has shown that GenderMag really helps improve inclusivity. Here's an example from a study in CHI 2019, which was actually done at Microsoft. In one of the tools, one of the teams did a user study. Again, they had only 2 genders in this case. The women are represented by orange bars and the men in blue. On first sight, you see that women fail at like almost double the rate at which men did. The team then did a GenderMag study and fixed the problems they found from the study. And they did the study again with a different set of users. The first thing to notice is that both men and women did better, and the gender gap disappeared. So GenderMag really works. But how do you actually systematize it into your software teams? To answer that question, we did action research method, and we collaborated with 10 teams. 5 of them were academic IT and 5 were from industry. We worked with the teams from about 5 months, in some cases to 3.5 years, helping them whichever way they wanted. We collected data, which was their GenderMag sessions, interviews, design meetings, emails, and follow-up. From there, we identified practices and pitfalls that these teams fell into. A practice or a pitfall was only considered, something for the paper if at least 2 or more teams faced it, and we have categorized them into these 3 classes. Let's talk about minimizing costs. Here, we have 3 practices and 2 pitfalls, and on the right side shows the teams that actually found the pitfall or used the practice. Let's talk about one of them, which is abstracting beyond. Gender mag-like testing is actually very concrete. It has very concrete inputs and very concrete outputs. But what these teams did that was really interesting was they were able to use the study session and abstract beyond to other UI patterns, which enabled them to reuse the findings from the session and the fixes they found. This is the example of Team C. They were creating dashboards for, this is academic IT and number of students registered. And one of the things they found is that it's just not one dashboard, even though we tackled only one, it actually is a starting point for all the other dashboards. But while doing this, one case the team fell into a problem, and this is actually a pitfall, is that you have to be careful in which UI or UI pattern you're evaluating, because if you do in ad hoc fashion, like in one of the cases, the feature that they were evaluating would not be in the real production environment. And then, it's not much use. Going next, so you can minimize cost. How do you maximize benefit? Let's talk about one, which is calculating bias. This is really a basic tallying at the end of the session. In this case, you find out there were no bugs in 41% cases or 46% cases, usability bugs in 3%, and in 51% of the cases, one of the Abby's facet was involved because this was done with the Abby persona. Such a debrief really makes it compelling, getting teams to see the big picture. Here is one example where Abby was violating a lot of our assumptions. It also helps generate some deeper, thoughtful discussions about their own styles that they faced. And it also helped jumpstart the fixes around the facets. So a lot of the failings were actually, we assumed our users will explode the system. They thought they were tinkerers. The next practice category, beyond session. Let's talk about the facet survey. Facet survey was a set of questionnaires from which individuals can figure out their problem-solving styles are more like Abby or Tim. This facet survey was actually created by one of the teams and there was taken up by other teams. They used it to recruit users for their studies. And what this was great was they could look for gender diversity as well as problem-solving diversity so that there were enough Abby's and Tims. They also used this to analyze their lab study data and measure the effectiveness of the fixed by focusing on facet by facet to prioritize and figure out how to do their fixes to the software. So in conclusion, GenderMag does help improve inclusivity. Research shows that. And in this paper, we were able to extract 9 practices to help with adoption and 2 pitfalls to guard against. Perhaps a central message behind this team's experiences is that suspecting your software of gender bias and wanting to fix it is all well and good, but integrating a systematic process can make all the difference. Here is a follow-up resources if you want to know more about it. But this is, I'll end here with the conclusion slide up and questions.
Thank you so much, Anita. And as far as questions go, there's one question already which says, can you give an example of a gender-related bug? Is it just in the UI or other code too?
So definitely in the UI it exists. So gender-related bug, what we have looked at is an end user trying to use their software, right? So it depends on the use case you're looking at. And let's take the one facet I talked about is learning style by tinkering. Just today I was looking at the GitHub UI and how to open a pull request. There's not much instruction given. You're supposed to just click on a button which says start a pull request, which goes to open a pull request page. And then there's another button that says, create a pull request. So this is a case where Tims who are open to tinkering, poking on the button and starting on works, but someone wanting a little more process-oriented learner tutorial might find it difficult. We've also looked at open source project and looked at documentation, the very information architecture, and how individuals process information can make a difference too. And I can talk more about more specific examples later.
Perfect. The next question is from Daniel, who's asking how much crossover is there in the kind of bugs found through this approach versus other bug finding techniques?
So when we say bugs, in our case, it's not that the system is going to crash, right? It's not that the end user is finding a system failure, which is more what testing and bug finding are. A gender mag bug or inclusivity bug in this case is the end user is having trouble, is finding some kind of barrier in getting to the thing they want. They might hit a wrong button. So a lot of these bugs might be seen as end user errors actually in software engineering parlance.
Okay. And then there's a question, an anonymous question, which is, are there pitfalls? Are the pitfalls bad for Abby, but good for Tim? Are these issues on a spectrum?
Let me see. The issues are definitely on a spectrum, but the pitfalls we talked about were more about when the teams did something and it did not result in a useful practice. So something that beyond our control was they evaluated a tool which was just a proxy and the new version had changed. So all the work they did in doing the gender max session did not work out. So the question you're really asking is some of the features might benefit Abby, but might not benefit Tim because they are on the opposite end of the spectrum. So if you want to create, and this we have seen that happens, if you go crazy on one end of the spectrum, it might harm other, and usability has to be thought about. So based on our HCI class, we had some teams go completely overboard and give instructions and process on every little feature, so much so the interface was totally cluttered, right? But the idea of gender mag is you want to make sure that Abby's are supported and the Tims are supported so that it helps the both end of the spectrum. So that's why it's important to look at both sides.
Perfect. There's one question, but we've run out of time. I'll give you the question and you can maybe talk about it in the video session is, can these personas lead to gender stereotyping and how do you avoid this? I think it's a great question, but unfortunately we are very close to running out of time. Like we have 4 minutes for another 8-minute talk. So I'm going to let you answer that in the video session after.
Mm-hmm.
Thank you so much, Anita. And the last talk is going to be from Jiwan, who's an assistant professor at Zhenjiang University. And it is a journal first talk on how does machine learning change software development practices. Jiwan, do you want to say it?
Yeah, thank you, May. Hi, everyone. This is Zhiyuan from Zhejiang University. Today, I would like to introduce our work published on transactions on software engineering. Machine learning has progressed dramatically over the past 3 decades, and previous studies in software engineering have put efforts into building tools for testing and debugging machine learning code and creating frameworks and environments to support development of machine learning systems. Despite these efforts, there are a lot of unanswered questions, like software practitioners still struggle to operationalize and standardize the software development practices of machine learning systems. So we are curious about how the use of machine learning in a system does or does not change software development. So to systematically explore the impact of machine learning on software development, we investigated 2 research questions in this work. The first is, how does the incorporation of machine learning into a system impact software development practices? And we consider the practices from Swaybook, the guide to the software engineering body of knowledge, and including requirements, design, testing, process, and etc. And the second research question is, how do the work characteristics from applied psychology like skill variety, job complexity, problem solving change when incorporating machine learning into a system? And to answer the research questions, we performed a mixture of qualitative and quantitative studies to investigate the differences in software development that arise from machine learning. we collect data from 3 different sources. First, we interviewed 14 software practitioners with experience in both machine learning development and non-machine learning development. Second, we derived a list of 80 candidate statements from the results of interviews and conducted 3 focus group sessions to reduce our list to 31 final statements for our survey. And lastly, we surveyed 342 respondents who reside in 26 countries across 4 continents around the world. And for the online survey, we recruited respondents from both machine learning and non-machine learning populations, and further broke down the survey responses by groups. Specifically, we asked the question, what best describes your primary product area you currently work on during the survey, and provided 5 options to capture the primary product area of our respondents. And the respondents selected 1 item from the option provided. Based on their selections, we divided the survey respondents into 3 groups, including 39 respondents who participate in machine learning framework and library development, and 59 respondents who are doing machine learning application development, and 342 respondents who are non-machine learning development. And in the survey, we provided the 31 final statements and asked the respondents to respond to each statement on a 5-point Likert scale, from strongly disagree to strongly agree, and to focus the respondents' attention on a particular area. We explicitly asked them to rate each statement with respect to their experience with the major product area they specified. And we then examined the distributions of Likert responses for each statement from our respondents. Finally, we compared the distributions in Likert scale for each statement between different groups of respondents using Wilcoxon rank sum test. In particular, we did 2 comparisons. First, we compared the distributions of agreement between machine learning and non-machine learning practitioners. And we then compared the distributions of agreement between machine learning framework library developer and the machine learning application practitioners. And the survey results confirmed 11 significant differences between machine learning and non-machine learning development at a 95% confidence level. And the 11 differences exist in software development practices and work characteristics. I will present top 3 confirmed differences with greatest effect size in upcoming slides. For skill variety, we observe a medium difference between machine learning and non-machine learning development. And machine learning practitioners are more agreeable with a statement, which indicates that machine learning development intensively requires knowledge in math, information theory, and statistics. And in terms of software design, we observe a small difference between machine learning and non-machine learning development. Machine learning practitioners are more agreeable with the statement. And this indicates that detailed design of machine learning systems is more time-consuming and tends to be conducted in an intensively iterative way. And with respect to task identity, we observe a small difference between machine learning and non-machine learning development. Machine learning practitioners are more disagreeable with this statement, which indicates that it is much harder to make an accurate plan for the tasks in machine learning development. And in this work, we answered the question that how machine learning changes software development practices by following a mixed qualitative and quantitative approach. And we found 11 significant differences in software development practices and work characteristics. Based on our findings, we presented the causes behind the differences as discussed by our interviewees, like the uncertainty in requirements and our algorithms and the vital role of data. We also provided practical lessons about preliminary experiments, reproducibility, and performance reporting, and highlighted several research avenues such as continuous performance measurement and debugging in our paper. And for more details and the implications, please refer to our preprint at my homepage. And thank you for listening. I'm okay for taking.
Thank you, Jiwan. There aren't much questions in the session. I'm looking at Slido and there aren't any questions. And since we are already 5 minutes into the next session, so we are going to close this. People who have questions for Jiwan, she's going to be there at the end in the beginning of the 3rd hour, where there is going to be, I highly encourage the speakers to be present there, and people who have questions can come in and ask them questions there. Thank you so much. And I'm sorry for the delay. And Emerson, you can start your session now.
Thanks very much. I'm going to share this next session. This session is sort of a continuation of the last session. And indeed, we have the same presenter as last time. So Zihuan's going to talk to us about what programmers are talking about on blockchain. Zihuan? She's still here. Okay.
Yeah, I'm sorry for the delay. Hello, everyone. Hello again. And this is Zhiyuan. Today, I would like to introduce another work. It is about what do programmers discuss about blockchain. And it is a paper published on transactions on software engineering. And the blockchain-related discussions become increasingly prevalent in programming question and answer websites, such as Stack Overflow and other Q&A websites in the Stack Exchange community. In analyzing and understanding such knowledge repository could provide key insights into the topics of interest to software practitioners. Most of the technologies previously studied via Stack Exchange communities often have long existence before Stack Exchange emerges as an important media for developer communication and knowledge sharing. In contrast to those technologies, blockchain is a nascent technology. Thus, we have a unique opportunity to spot how a development community grows its knowledge in a particular domain. In this work, we considered 2 data sources, Stack Overflow and blockchain-related communities on Stack Exchange. And for the posts on Stack Overflow, we use keyword searching and tag filtering to identify over 3,000 blockchain-related posts. And the process is similar to prior work that analyzes posts on Stack Overflow. And on Stack Exchange, we searched through all the Stack Exchange communities and identified 2 blockchain-related communities specific for Bitcoin and Ethereum. And the Bitcoin community contains around 17,000 question posts, and Ethereum contains around 12,000 question posts. And we would like to use topic modeling to automatically identify discussion topics, but a simplicity use of LDA is not capable of dealing with our case, because LDA captures the topics blindly without keeping in mind the variety of dataset and the domain-specific concepts. Specifically, on the one hand, LDA is biased towards larger-sized corpora. In our case, discussions in more active and long-lived platform like Ethereum would account for the dominant proportion in the dataset. On the other hand, LDA-derived topics are not linked to higher-level domain-specific concepts. Thus, the derived topics are not suitable for analyzing commonalities and differences across platforms. To address the aforementioned challenges, we proposed an approach that combines a balanced LDA with the reference architecture of a domain. The methodology includes 3 steps. First, we categorized our dataset into 5 corpora based on blockchain platforms and applied LDA to each categorized corpus independently. And second, we derived a reference architecture of the blockchain domain by referring to multiple sources, and the reference architecture contains 6 layers. Finally, we mapped the varying topics across different blockchain platforms using the reference architecture that we derived. I will highlight some interesting findings in upcoming slides. First, we discovered 45 topics from our dataset. The topics are distributed across 4 platforms and 6 layers in the reference architecture. In particular, we find 10 topics for Bitcoin, 10 for Ethereum, 15 for Hyperledger Fabric, 5 for Corda, another 5 non-platform specific topics. And the figure shows the popularity and impact of architecture layer topics over the time period from May 2011 to November 2017. For topic popularity, the application layer topics exhibit the highest popularity of over 33% in blockchain discussions. And in terms of topic impact, the application layer topics grow fastest compared with topics of other layers since November 2015. We also observed that among application layer topics, the evolution of topic impact is strongly associated with cryptocurrency market price. In particular, the topic Bitcoin cryptocurrencies is strongly associated with the market price of Bitcoin. The topic Ethereum smart contract topics is also strongly associated with the market price of Ether. In this work, we aim to answer the question what programmers discuss about blockchain. To tackle with the technical challenges, we propose a 3-step methodology to analyze blockchain-related posts on Stack Exchange communities. We highlighted some interesting findings about blockchain-related topics. And for more details and implications, please refer to our preprint at my homepage. Thanks for listening.
Thanks very much. So don't see any questions on the Q&A, but I had one, which is on prior slides, you talked about sort of the relationship between topic popularity and currency value, I think. Could you speculate a little bit about what you think the causal relationship is between the two, or whether it's the 2 changes are caused by something else? What's the relationship, do you think?
I think I think the rise of the market price may address some attention from the population. So there might be some correlation, but there also there might be some other factors that may attract more people to join the community. So that may leave for our further investigation.
All right, thanks very much. You all can talk to the speaker offline in Clouder. Thanks very much. Okay, next up, we are going to hear about bounties and technical Q&A sites, another study of Stack Overflow, and Jia Huan is going to talk to us about that next.
Greeting everyone, I'm Jiajun Zhou, a third-year PhD student from Queen's University, and I'm
so
also
could you share your screen with us? The screen sharing doesn't seem to be working. Thanks very much. Perfect.
Okay, so greeting again, I'm Jiajun Zhou, and today I will present our paper, which is a case study of Stack Overflow Bounty. This paper is done together with Shaowen from Mississippi State University, Hopper from University of Albert, and Ahmed from Queen's University. So due to the power of crowdsourcing, Stack Overflow has become an essential tool for developers. From this figure, we can find the number of new questions rapidly increasing. However, the number of solved questions is dropping. It is becoming difficult to get an answer to all questions. In an attempt to improve the visibility and bring attention for unsolved questions, Stack Overflow introduced the repetition-based bounty mechanism to motivate the user to solve questions. In this mechanism, a user can offer repetition points as a bounty on a question. The bounty question will be highlighted with a special tag and shown on the homepage of Stack Overflow. So more specifically speaking, on the third day after a question is asked, everyone can propose a bounty on it, and the bounty will be inactive for 7 days. The user can award satisfied answer between the 4th day and the 11th days. With a preliminary study, we found that the long-standing unsolved question with bounty are more likely to be solved compared with the question without bounties. In this figure, the x-axis is the question remain unsolved after 100 days, and the y-axis is the question solving rate. We observe that for the long-standing questions, the solving rate is 50% for the bounty questions, and only 1.7% for the non-bounty questions. Although bounty have been used since 2009, we still don't know how helpful are bounties in solving questions. For example, what is the association between the bounty and the solving likelihood of questions? Will bounty help question get solved faster? So in order to answer such questions, we collected around 129,000 bounty questions and 12 million non-bounty questions. Then we extract 42 study factors. These factors are non-bounty related, user related, question related, and tag related tags. We consider the last 3 types of factors as the control factors in our study. As for the methodology, in order to capture the nonlinearity of the association between study factor and the response factors, we employ the nonlinear logistic regression model in our work. We also use AUC to evaluate the performance of the model, and the y-chi-square test to interpret the impact of factors in our models. To study the solving likelihood of bounty questions, we focused on the solved and unsolved bounty questions. Firstly, we conduct a Spearman rank correlation test and the redundancy analysis on the study factors, and then construct the solving likelihood model. In order to study the solving speed of bounty questions, we focused on the fast and slow solved bounty questions. Then we conduct the same analysis to build solving speed models. The median AUC for the solving likelihood model is 0.71, and for the solving speed model is 0.82, which indicate our model explain our dataset well. We observe that the bounty value is important in the solving likelihood model. The figure shows the solving likelihood of bounty question against the bounty value. With a higher bounty value, the bounty question is more likely to be solved. We also find the timing of offering bounty is very important. The earlier offer a bounty to a question, the higher likelihood of the question to be solved. However, we found that the bounty-related factors are less important in your solving speed model. The question-related, user-related, and tag-related factors are more important than bounty-related model. Especially, a higher valued bounty does not help question to get solved faster. My research focuses on the monetary, non-monetary extrinsic incentives in crowdsourced software engineering. We have another work regarding monetary bounty in GitHub. Welcome to check that work if you are interested. To summarize our study, we studied the bounty in Stack Overflow. We collect 129,000 bounty questions and extract 42 factors for our study. We observed that the long-standing unsolved questions with bounty are more likely to be solved. We also observed that bounty are not a silver bullet for getting a question solved faster. Thank you. I'm finished, and welcome for any questions.
Thanks very much. One question I had was, you talked about the, you're talking about bounties here on Stack Overflow, and as you mentioned, there's prior work on bug bounties in particular, lots of them around security bounties. Could you talk about what some of the similarities and differences are between the effects you see for bug or security bounties compared to bounties on Stack Overflow?
Okay, so the motivation is very different. One is driven by the reputation point, another one is driven by the monetary reward. So that is the biggest difference, and it will lead people to different motivation to solve the question. For example, in this study, in Stack Overflow, the bounty value cannot motivate people to solve that question as soon as possible, because reputation is kind of help them to win a community recognition, right? And as for the monetary reward, that is the true money. So people maybe were more eager for that things. So in the bug fixing scenario, for the project that never used the monetary bounty before, the higher value of the bounty will increase the solving speed and the solving likelihood of that. But here in Stack Overflow, the value cannot make the whole process faster. So that is just the one case. So if you are interested, I'm happy just to check out another work.
Great, thanks very much. There's one question here from Clouder. How do you see the bounties being integrated in other platforms like GitHub?
This is integrated in other platforms like GitHub. It kind of sensitive because in Stack Overflow it is the reputation point. But in GitHub, people will more prefer for the monetary reward. But if GitHub introduced this kind of a feature, people were kind of concerned that whether the developer will be biased because of this kind of monetary reward. But for now, GitHub already introduced the donation features. I think because the donation is for the whole project, not for one or two specific issue report, and people can stand with that kind of bias happens maybe. So, yeah.
Great, thanks. Thanks very much. We're about out of time. Alrighty, so next up, we have a talk about using bots to answer questions from software repositories, and Ahmad is going to talk to us next about that.
Hello everyone, my name is Ahmed Abdel Latif. Today I'm presenting our work that use bots on the top of software repositories to answer developers' question. This work was done with my colleague Khalid Badran under supervision of Dr. Imad Shihab. Software repositories contain a large amount of data that can help to improve the quality of the software development process. However, previous studies show that extracting useful information from these repositories remains to be a difficult task. Why is that? This is because getting answers from repository, some information requires that user navigate through a lot of data or extract and link data from different sources. Extracting useful information is considered to be a challenging task. This is because of the lack of tools to support the data extraction from the repositories. Also, in many cases, project stakeholders need special expertise to mine their repositories. And even if the stakeholder has the expertise to perform such a task, it requires a dedicated effort and time. To overcome those challenges, we present an approach to answer some of the most common software development and maintenance questions that face developers using a bot that is layered on the top of software repositories. Here is a snapshot of a developer chatting with the MSR bot, where at first the developer greets the MSR bot and then asks about who created a certain file in the project, which is in this case Kafka admin client.java. And here the bot replies with the name of the developer who created the file. Finally, the bot is asked to find developers that asked most bugs in that file. Say, in case you find an issue in that file and want to find the people with the most experience to deal with it. The MSR bot here replies with the names of the top 5 developers who fix most bugs in that file. To evaluate our MSR bot, we devised 3 research questions. First, we need to evaluate whether the answer returned by the MSR bot is useful in answering the participant's question. Since bots are meant to answer a question in a chat-like form, speed is of the essence. Therefore, in the second research question, we measure the user's speed while performing tasks related to their repositories using the MSR bot. And finally, it's critical that the MSR bot returns accurate results, as software practitioners generally act on this information, sometimes derive major tasks. So we evaluate the accuracy of the MSR bot in the third research question. To answer our research questions, we constructed a case study. First, we surveyed work that investigated the most commonly asked question of software practitioners. Next, we developed the MSR bot to answer those 15 questions. Then we applied the MSR bot on Hibernate and Kafka software projects, which have more than 100 releases and more than 6,000 commits and issues. And finally, we asked 12 developers to perform 10 tasks that formulate from 10 randomly selected questions, once while using the MSR bot and another without using it, where we call it baseline. The result of our first research question showed that most of the developers found that the MSR bot is either useful or very useful on a Likert scale. On the other hand, 10% of the developers said that some information is missing in the bot's answer, such as commit hash. As for the second research question, we measured the task completion time and find that the approach of using the bot takes significantly less time than the baseline approach, whether we are considering all tasks, completed and uncompleted tasks, or only the completed ones. Finally, we evaluate the accuracy of the MSR bot because it's critical that the bot returns the correct results. The results show that the MSR bot achieves an accuracy of 90% in answering the user's question, which is higher than the baseline accuracy of 25%. Next, we did a follow-up interview with the developers to understand what they felt were the strengths and the areas of the improvement for the MSR bot. One of the participants pointed out that the ability of the MSR bot to provide answers from a rich history very quickly. Another participant suggested that a clear improvement is to support more questions. And another participant recommended to allow the user to dive more into the bot's results as a potential future feature. While building the MSR bot, we were faced with many challenges, which we think also apply to many other software engineering chatbots. So first, we needed to carefully select the best natural language understanding platform for the software engineering domain to accurately understand the user's question. Another challenge was the lack of the software chatbot training data. So we had to generate our own by piloting the chatbot. And finally, we needed to expect the user behavior and maintain the conversation flow at all times. To conclude our presentation, first, we present our motivation, then we explain our approach and case study and present our results. And finally, we present the challenges that face us while developing the MSR bot. Thank you for your listening.
Thanks very much. So we have an excited fan on the chat here for you. Anonymous asks, is the MSR bot available as an online demo for us to try out?
It will be, it's currently under development and expect to be very soon online and publicly available.
Great, thanks very much. One other question I had about the talk is, could you give just an example of what one of the 15 questions were and a little bit about how the developer answered it.
Can you repeat the question again?
Yeah, could you just give an example of one of the questions and how one of the developers answered it?
You mean in the baseline?
Either way, or how about with MSR bot?
Okay, so first of all, we formulated the questions as tasks in order not to bias the participants in our work. So for example, one of the question, show me, for example, who committed last week, for example, or show me the list of files that introduced most of the bugs. Where in this question, that to answer it, you need to link the Git information with the issue tracker information, which is in this case, the Jira. So the developers or the participants in our work, they ask the question sometimes directly. So for example, who committed, who did some commits last week, or who committed last week, something like that. But for the baseline, the developers used actually different ways to answer the question. Some of them navigated through the history of the commits to search for an answer. And some of them, for example, went to the Stack Overflow to get the commands to do that. And another participants, they cloned the repositories and they wrote a script to clean and extract the information that answered the data.
Great, thanks very much. That sounds very painful to do without MSR bot. All right, that's all we have time for questions. There's one more question online, which you can ask and take offline with Fernando Castro.
Sure.
All right, thanks very much. The next talk we have is about when questions are being closed and NLP pre-submission predictions for question closing reasons on Stack Overflow. Laszlo is going to give this talk.
Yes. Hello, my name is Laszlo Tóth and I am a PhD student at the University of Szeged. In this presentation, I will demonstrate a new research direction of our research group, which aim to support the users of Stack Overflow to pre-evaluate their questions before posting it to the site. So, what is our motivation for this research? Stack Overflow is probably the most influential community question answering site for the software engineering community. It has a very high frequency of posting, 11 million registered users and over 6,500 new questions posted on the site every day. So Stack Overflow undoubtedly become an essential technical knowledge repository in programming. So given the extreme posting frequency, moderator work is undoubtedly an elaborate and challenging task. Simultaneously, moderation is the key to avoiding the issue of the quality decline, which is highly important for the sustainability of the service as Stack Overflow provides. So briefly, to maintain a reasonable level of quality, supporting poor questions should be avoided, and closing or deleting them is often inevitable. Nevertheless, the definite reasons for closing particular posts is often unclear to the users, leading to heated debates in some cases. In this slide, the outline of our experiment is presented. So data set for this study was taken from the Stack Overflow data dump created on 4th of March 2019. Both open and closed questions posted before 2013 June, the introduction of the currently available closing policy and reasons were filtered. So questions for before that date were filtered out. Question closed due to the application were also excluded from our dataset because of two reasons. This problem has already been well examined previously, and finding the application would imply the knowledge of the previously posted question, which is the opposite of our purpose of using only pre-submission information. The final dataset consisted of 207,040 closed questions. And as usual in machine learning, we balanced our dataset by randomly sampling the same amount of open questions. No further filtering was applied. Several text preprocessing steps based on the conventional NLP methods, such as cleaning, tokenization, stemming, were applied to create the classifier's input. Part of speech tagging employed for the body and title text to better distinguish polysemic words improved both the precision and the recall in our calculation. We had two experiments for binary. Between the open versus closed questions, we tried decide to a question remain open or will be closed in time. 3 different recurrent neural network models were defined and used in both experiments. The second experiment is the 5-class classification, predicting the different closing reasons versus the open state. So we applied 3 different neural networks, which is based on an embedding layer that creates a dense vector representation of the input, followed by GRU unit. The difference, the 3 RNN neural network lies in the topology of the GRU layer. In this slide, the results of our experiments can be seen. On the upper left, the results of the binary classification, whereas on the right bottom, the results of the multi-class experiments are seen. As only the press submission textual information of post was used as input in our study, and we directly classify question into closed versus open graphs. The number of related studies in the literature is rather scarce. Although the results can not be compared directly, we have juxtaposed the results of the similar research as it can be seen on the bottom left. It can be seen that our best results, which is the 71.87%, is reasonable for the binary classification. Our study is the first to report the prototype of multi-class classifier estimating the exact reason for closing. With the same textual input used in the first part, our GRU model achieved 48.55% accuracy in predicting one of the available closing reasons, which is much better than a random guess. It is also worth noting that in the currently used voting-based closing policy on Stack Overflow, a lack of consensus among the votes often occurs. Interestingly, the very same disagreement also appears in our machine learning approach. This phenomenon is well represented with the confusion matrix. And the conclusion, it is feasible to build a classifier that predict the possible fate of the question intended to pose to the Stack Overflow. The prediction is based on only textual information available for the questioner. The confusion matrix reveals that the highest variance of the model occurs at the same closing reasons, causing the most disagreement among the human moderators. The models and the process are under improvements. The accuracy of the prediction has been improved significantly in our current work. The misclassification is under a more in-depth investigation. And thank you for your watching.
Thanks very much, Laszlo. We're about out of time and we need to move on to the third presenter, but the last presenter. But you can talk with Laszlo in the lobby's video chats if you'd like to ask him questions. Thanks very much. All right, next up we have interpreting cloud computer vision pain points, another Stack Overflow study, and Alex is going to give this talk.
Thanks, Emerson. I'm just trying to share my screen, but there we go. 1 minute. Perfect. Well, thanks, Emerson, and thanks everyone for joining today. My name's Alex Komodo, and I'm from the Applied.
Alex, your video and audio are good, just can't see your screen.
Oh, okay. 1 second. How's that?
Perfect.
Perfect. All right, there we go. So yeah, as I was saying, I'm from the Applied Artificial Intelligence Institute at Baekje University, and today I'll be presenting our mining study of Stack Overflow questions on computer vision services. So I'll start off with the topic of the machine learning spectrum, which is gaining quite a bit of traction in the software engineering community, especially if we look at it from the software developer's perspective. Here we can see on the left-hand side that developers can set up a training infrastructure and implement machine learning algorithms on their own, but this can be quite confusing without prior expertise. An abstraction on top of this would be to use a machine learning framework like TensorFlow to plug in a pre-trained model, but that still requires some basic understanding of machine learning lingo and foundational principles. A completely different approach, which is a lot easier for developers, is to just use a cloud-based service that provides the power of ML through RESTful API endpoints. And through the use of these cloud-based endpoints that developers are already used to, such services have now been dubbed as developer-friendly ML. And we wanted to explore these developer-friendly services further. We've seen recently an explosion in these types of services, especially for computer vision. And the computer vision services is the real focus of my talk today. If we look at the marketed promises from vendors, we can see that developers can tap into human level intelligence using these services. So, for example, they can build a custom AI application without a PhD, or they don't need to build, maintain, or upgrade deep learning pipelines to get the job done. So it sounds almost too good to be true, and we'll look into a few pitfalls. In short, the state of the art of computer vision is good, but it's not perfect. For example, some of these services can mislabel images entirely when a bit of noise has been introduced to the image. And similarly, they can fail when even a single pixel has been modified. They're also easy to fool through the use of adversarial examples. And longitudinal studies have found evolutionary and ontological issues of these services as well. So our aim is to better support vendors through improved service design and documentation. And we wanted to achieve this by looking at the root cause of the problems that developers face as they use these services. One way to do that is by investigating Stack Overflow posts. So as you can see here, the growth of these posts it has been increasing for a number of years. And so developers' interests and questions on these services are increasing. Thematically, we find that developers are discussing similar issues as well. So here are a few high voted questions. Firstly, they're unaware of machine learning vocabulary, such as what score or confidence means. They're frustrated by non-deterministic results. So the service can recognize some things at times, but other times it can't. They're unaware of the limitations behind what the service can and cannot do. So they're overestimating what the service can provide. And developers also seeking better documentation as well, such as what labels the service can classify. So we formulated 2 research questions to investigate these themes further. Firstly, we wanted to see how developers misunderstand the nature of these services through the Stack Overflow questions that they post. And secondly, we wanted to see if the distribution of these types of issues are similar to those in existing studies. Our mining method started off by defining a list of 229 intelligence services. We optimized our search query and extracted 21,000 questions. We then refined these questions to computer vision exclusively. With multiple coders, we manually classified each question to an issue type using 2 taxonomies. And lastly, we compared the distribution of these classifications against prior studies using a chi-square test. So to classify those issues, we used 2 existing classification taxonomies. On the left here is our first one, and it's a classification taxonomy around software documentation issues. And on the right is a classification taxonomy on generalized Stack Overflow questions in the domain of Android issues. So of course, as we're not the original authors of these papers, we provided our interpretations of both taxonomies, and we'll get to some results. So when we compare the documentation issues to existing literature, we find that there's a greater demand for further documentation in these services. Developers are also more prevalent to question the accuracy of computer vision service documentation more than they do in existing SDKs. And they're also far more concerned about the usefulness of this documentation when compared to prior work as well. We observed a medium-sized effect between the 2 studies. Now, when we contrast our issues against a more mature domain like Android issues, we see that there are a lot more questions on basic error handling. Regarding the API usage, we find that developers are questioning the behavior and function and limitations of these services as well. And lastly, basic machine learning principles are largely misunderstood, suggesting conceptual misunderstanding as well. In essence, more mature domains like Android show a large distribution size effect compared to the issues that we explored on computer vision services. As an interpretation of our findings, we looked at classifying a sample of our posts into dimensions of the Bloom's and Solo learning taxonomies. And we found that a larger number of these questions fell into the lower constructs of the taxonomies. So this suggests that many of these issues can just be alleviated through improved documentation. However, some developers are asking questions at the higher level knowledge constructs, and these can't just be resolved through improved service documentation. So therefore, improved educational practices are likely needed moving forward. And so we'll need a mix of both documentation and education. So this leads us to a few recommendations from our study. To begin with, we have some recommendations for vendors. And we suggest that the descriptions of these services need to be a bit more explicit. They aren't the silver bullet, and we shouldn't be setting developers' expectations too high. Vendors also need to clarify the use cases for these services. So are these the right tools for the job? And furthermore, what remains the responsibility of the dev? How can they integrate their application into the service? And what does the developer need to do? Do they need to pre-process data before sending it to the service, or does the vendor do this? In essence, we need to stop oversimplifying the nature of these services and stop making it sound like just another typical cloud service, because the non-deterministic nature of machine learning really impacts this. As for developers, we suggest that they develop a better understanding of the context before diving into these services. So they need to think about how these services evolve and does it actually do what they're after? Perhaps they shouldn't be fooled so much by marketed promises. We also suggest that they read up on the vocabulary needed to use these services, especially the vendors' vocabulary, because they do differ between each service. We also emphasize that developers should explore further education to obtain a greater appreciation of the nuances of ML before diving into these services as well. So on that note, we have a few recommendations for vendors, namely that we need to start developing the next generation of software engineers on the higher level aspects of ML. Much of the background in the nature of ML and AI needed to use these services has focused on the context of data science communities, but there's a little bit more needed in developing this for software engineers. So, for example, we need to develop a crash course aimed at software engineering undergraduates in ML and AI to highlight the nuances of these services, almost analogous to introductory programming classes. This might involve the need for pre and post processing, the instability of these services, and the specific algorithms that power these APIs and their limitations. Furthermore, we need to educate on model evolution and the impact this has on the quality of systems. Lastly, for us researchers, we should repeat a study like ours in a few years to assess how this emerging field is evolving and whether developers have attained a greater maturity of these services. We also suggest that we can mine usage patterns from open source software to see what the technical challenges are at the implementation levels. And this could see if the API usage patterns evolve when we use these services and the rise of AI-based applications. So that's all from me. Thanks for listening. Please feel free to read our paper, and I'm glad to answer any questions. Thanks.
Thanks very much, Alex. Well, people are putting the questions into the chat. One question I had was, you looked at Stack Overflow as a way of understanding what the pain points are with the service. Could you comment a little bit more on a high level about to what extent pain points are accurately represented in Stack Overflow compared to maybe things people aren't talking about on Stack Overflow that might still be pain points?
Yeah, I see. So specifically on Stack Overflow, the reason why we chose it was to target the root causes of the issues that developers are facing. So we could have mined other areas like, existing software that's using these services, such as open source software. But we really wanted to narrow down on, like I said, the root cause of what developers are facing. So what we did notice, what was lacking in the literature for these Stack Overflow questions was that a lot of Stack Overflow questions have looked at the what is and not the how to fix it. So classifying questions based on the themes of the types of applications that developers are building, but not necessarily on the root causes for us to address. So, I mean, it's a great point that we can start investigating these areas further into other aspects. But yeah, that's just a direction that we're looking at for future studies.
Okay, thanks very much, Alex. That ends the session. So next up, all of you who are listening, you can look for the presenters of the session in the lobby's video chat during the third hour if you want to ask more questions. Also, don't forget to visit the posters and demos today in the third hour by going to Clouders Exhibit Hall and joining the presenters in their own video chats. Thank you and enjoy the rest of the conference.